So as the next thing to go ahead, I'll call my team member, Mr. Diptangshu De. So I think you will be delighted to know that FOSSEE IIT Bombay is also developing the GUI for OpenFOAM software. So we have the team members, Mr. Rajdeep Adak, he's working from the US, he's doing masters there, and Mr. Diptangshu De. So Diptangshu will show you some of the demonstrations, some basic demonstrations which he has come up with.
So hello everyone, I'm Diptangshu, and I'm working on developing a GUI for OpenFOAM, and the current version of this GUI is based on Blender, because Blender if anybody is not aware, Blender is a 3D software, and it has excellent meshing capabilities, and it is also open source. So with the help of Blender's Python API, we are able to make an add-on that would help us to generate block mesh files, and it eases the process of generating the OpenFOAM case files for us much easier. So the current state of the add-on is that we can generate block mesh dict files from it, and I'll be showing a quick demonstration here by making a basic Venturi tube. So in my screen you can see this is our panel for our add-on, which is called Venturial. We can select our case directory. Here I will select a directory called GUI test here, and it automatically detects the case name. So since the parent name is GUI test, the case name is set as GUI test, and the mesh directory is block mesh dict. If we want, we can change the directory of the block mesh dict file to somewhere else. Right now we'll keep it as defaults. So once we have set the case directory, we can move on to the next part, which is actually manipulating a geometry. So this add-on currently is being developed with academia in mind, and its primary use case would be to educate students on how OpenFOAM works actually, and how each of its meshing utility works. We will add more complex meshing capabilities later on, but currently we are generating geometry in such a way it makes it easier for any students who is learning OpenFOAM or learning the block mesh dict tool. It makes it easier for them to understand. So here, to generate a geometry, we will have to select, we will go to the geometry tab in the panel here, and we will select the number of blocks that we want. So in my case, in this Venturi tube, I want 3 blocks. I will enter the number as 3, and each block will be a hexahedron, and it will be entered in the grid space. So I will click generate blocks, and you can see 3 blocks have been generated. Here using this panel is using Blender's inbuilt meshes to generate the geometry. It is suggested to make the meshes using the panel and not from the Blender's inbuilt add mesh features, because that makes it difficult for the add-on to detect the geometry. Now once the blocks are added, we can edit edit each of the blocks as we want. So let's say if we are modeling a Venturi tube, it can go like this, and let's make it a slightly bigger here. So here I have my shape for a basic Venturi tube that I want. Okay. Then to start my processing on it, I will just select everything, and I will first compose the mesh. So what it does, instead of it being three different meshes, it composes everything into a single mesh. So if I just remove this, and I will just undo this operator. Oops. So yeah, as the add-on is still in the development phase, so there are some instabilities that cause this bug. Just a moment. Here. So as you can see, currently each of these blocks are their own separate geometries. So in order to start working on this and generate a block mesh dict file for this geometry, we will need to compose this, compose all the geometries that are present. So first we will compose them, and then we will get the vertices that are in this file. Then we will get all the blocks that are there in this file. So here you can see in this list, in this view, all the blocks that are present in this geometry is listed down here. And right now, for the grading, I have by default values are 1, 1, and 1. If I want to change my grading, I will just delete all the selected blocks, and I can give some custom values. Let's say 10 along Z. And then if I generate the blocks, you can see the blocks are generated, and the data is shown here, which is analogous to the OpenFOAM code. So hex and the list of vertices, the grading that I'm using, and the number of cells. So moving on, after this, we can assign the boundaries to each of the faces. So for that, we will have to go to the face select mode, and I will just select each of these faces and assign a boundary. Assign a boundary type to each of these faces. So let's say this will be my inlet, which is a patch. This will be my outlet, which is also a patch. And you can see as I'm adding the boundaries, these are those boundaries are being listed over here. So if I select these three, and I can make it as top wall, which will be a type of wall. These top walls are added. I will add a bottom wall, and the rest I will list as side walls. There. So all the boundaries has been defined over here, and we can finally exit the face select mode, and now basically our mesh is ready to generate our block mesh dict. So before I generate the block mesh dict, I would like to also point out that we have a few visualization features right here been built in the add-on. So for example, we can visualize the vertex indexing that is going on here. So we can see that which vertex have been assigned which numbers according to the OpenFOAM, according to how OpenFOAM processes data. We can change it to see the coordinates of the vertices, as you can see. And if it's better, we can just change the color to see it better. Yeah. So these are the different tools. We can also check the boundaries that we have defined over here. And a few glitchiness is there because it's still under development, which will be fixed in the release version. So once my mesh is basically ready, I can just generate my block mesh dict, and yeah, it's generated. Block mesh file is generated. Now I can just show you. So in the Explore, GUI test was my case file. If I open my file manager here, you can see the block mesh dict file is generated, and this is how it looks. It has generated the complete block mesh dict file, and if I want to open it in Parafoam, by ParaView, I can do it right now by I will just copy this and paste it in a already built OpenFOAM case file. So I'm just reusing another case file over here, and I have my OpenFOAM environment open. So I will just run the block mesh utility. Sorry. Here. So before that, let me just show you. Here, this is the block mesh dict file that I just generated. And now if I run the block mesh utility, it executed all fine. And if I run Parafoam now, apply, you can see this is the same geometry that we created before. Now here it appears vertical because of the axis orientation, And as you can see in Blender, the default by default the X and Y plane is in the horizontal direction, whereas in ParaView the X, Y plane are vertical. So if I just rotate it this way, you can see that the mesh is generated all right. And if I just change the view, you can see that even the cell distribution, the grading is also displayed all right. So this is the current state of the GUI that we have built. Moving on, we will the upcoming features that needs to be added are capability for edges and all. And yeah, that's the current state of the OpenFOAM GUI. Any suggestions that other professors might have regarding this software are always welcome.